Let's talk about modern energy networks. We're talking about a scale that is just staggering. And the real challenge? It's not just about getting through the day. It's about making huge, long-term strategic decisions with confidence, even when everything feels incredibly complex. Okay, so let's set the stage. The modern networks challenge.
Think about it. We're making literally thousands of decisions every single day.
And every one of those decisions impacts billions of dollars in assets. So every single station isn't just a pin on a map. No way. Each one has its own cost, its own risk, and yeah, its own opportunity.
This complexity forces us to ask a totally new strategic question. We're moving from just thinking about efficiency to thinking about existence itself.
And this is where it gets really interesting. The whole game changes. You see, the same engine that optimizes trips day to day, well, it can also optimize the very existence of stations over years. So, how on earth do you do that? Well, you start by building a digital twin. You're basically taking all that chaos and turning it into crystal clarity. Phase 1 is all about data. AI planning starts by pulling everything together. Operational data, commercial data, site data from, those old spreadsheets. It all gets unified into one single source of truth. Then in phase 2, that data gets a serious upgrade. We feed it into what we call a digital brain. This thing contextualizes all that information with real market intelligence. It's not just numbers anymore, it's the reality of how the network actually performs. And here's the kicker in phase 3. This isn't just a snapshot. The system applies all that intelligence across different timelines. What's happening today, what we need in the midterm, and what the entire network should look like years from now. Okay, so we have our intelligent digital twin. Now the fun begins. We're moving from just watching to actively proving the path forward. We go from a hypothesis to a proven decision. How? We simulate everything. What if we close this station? Okay, the system reassigns the demand. Then it re-optimizes all the routes. And then, the most important part, it measures the real impact on the bottom line and service. It's like a stress test for every possible future.
So you run millions of these simulations. What do you actually get at the end of all of that?
You get this. A clear, totally data-backed verdict for every single station. No ambiguity. It's either keep, upgrade, mothball, or sell. It's a strategic roadmap, plain and simple. But we're not done. This isn't a one-and-done analysis. Now we talk about governing with confidence, with a network that continuously learns. For the executives, the outcomes are exactly what you'd hope for. A big financial uplift, a healthier operation, and decisions you can actually stand behind because they're backed by rock-solid data. And when we say big uplift, we're talking over $15 million in estimated net EBITDA. That's not theoretical, that's real, tangible impact. And this is maybe the coolest part. There's a feedback loop. What actually happens out in the market feeds right back into the system. So it's constantly learning, constantly getting smarter, and its recommendations just get sharper and sharper over time. At the end of the day, what you get is a network where every single station's existence is completely justified by profit, by coverage, and by capacity. This is how the network is governed, not guessed.